So our final lesson for today is on the sine law, which is section 5.6 in your textbook. You can feel free to pause the video if you want to reference that. And what you see on the chalkboard are the two sine laws. Now, some schools and some teachers only teach one of them because technically they're just reciprocals of each other. But I like teaching our students both of these, and there's a reason why. The first one, the sine A over A equals sine B over B equals sine C over C, and I think a lot of you understood the angles on the top and the sides on the bottom. This is to find a side. I said that wrong. To find an angle. Okay? So this one's used to find an angle. And again, for some students, they find this confusing. They don't really care. They say, I don't really care as long as I know where my unknown is. But usually, most students like it when our unknown is in the numerator. It's just easier to manipulate. So the one at the bottom, again, it looks like it's a brand new one, but it's just the reciprocal of that. This is to find a side. Small disclaimer, this one is actually hard. This is a hard concept in grade 11. And we'll explain that hopefully when we have our synchronous classes online in the afternoon. So let me just talk about this question. I'm going to make up a question if that's okay, to find a side. I'm going to make this one up and how we use it. Let's just say this angle was 40 degrees. We'll call this angle A. And this angle here, let's call it angle B, which is maybe 73 degrees. And let's just say we have a side B here as well, which is, let's say that's 9.2 units. And let's just say we want to find, we should put a C. Find side C. So I'm going to walk us through this, but Karen, you wanted to say something? You want to ask a question? You wanted to do it?
No.
Ladies and gentlemen, Karen at class wanted to do this question, but now she's saying no. She's a gem. Anyways, so I'm going to walk us through this question. This question, clearly you can see that there's two angles and a side, and this pattern is known as ASA. ASA. And the reason why, with any two angles, we can actually find the third angle with no problem. Can someone actually help out Mr. Chen? I know this is a sketch, but do you think you can find out angle C? I know a lot of you realize why I'm doing it. I'll explain in a moment. But can someone help out Mr. Chen? What is angle C? Claire, do you actually know what it is? 67 degrees. And the reason why she got that is because Claire knows that 180 degrees is the total sum of a triangle. And if you add 40 degrees plus 73 plus angle C, rearranging, that should be 67. Right? So this is the proof what you learned in grade 9. Interior sum of a triangle adds up. Let me see that recorded. Yes, it did. My head was in the way. Okay? But now the reason why we have 67, this question can actually be set up. The problem with this, though, is sometimes students will try to do cosine law. And again, cosine law requires two sides. This one only has one side. So maybe this is what you were asking earlier. But that's why we have sine law. So how am I going to set this up? Watch what I'm going to do. Because we're trying to find side C, C over sine C is equal to, now let's take a look. I can't really use angle A and side A. I can't in this example, but I think we have an angle B and a side B. So I'm going to set this up here. Before we continue, any questions from the class? And again, if you're at home, feel free to pinch in and zoom or pause the video and ask us stuff. I'm running out of room, so let's move over here. We just plug in some stuff. C over sine of that 67 degrees is equal to, what's side B? 9.2 over the sine of 73 degrees. So just be careful. You don't use all the numbers sometimes simultaneously. Sometimes you have to be critical thinkers and realize what you need to do. Notice most students do not memorize what the sine of 67 degrees is. Notice most of us don't memorize what sine of 73. We use our calculator. But we still do manipulations, and a lot of you realize in order to move this sine 67, it doesn't get moved, we multiply both sides by sine of 67. So 9.2 times the sine of, that should say sine of 67 degrees, all over the sine of 73 degrees. And again, I just made up this question. So if you're working from home or you're working in class, all you do is just 9.2 times the sine of 67 divided by the sine of 73. And let's get this to maybe 1 decimal place. Our final answer, hopefully someone in the class will verify with Mr. Chen that he's correct. We get 8.855, which of course rounds to 1 decimal place of 8.9. Is that good? Thank you so much. And that's how we actually do this kind of question when finding a sine. Finding a sine.